So moving on to question 6 here, we have a question on functions. So it's split up into a few parts, so it kind of follows quite nicely, and for part A, we're just given a little bit of a composite function question, and we're asked to find the value of g of 0. So g of x is this function here, so it's a composite function of g of x into g of x, but we're asked to work out g of 0 first. So g of 0, or g of 0, sorry. But first let's work out what g of 0 is, and then once we've worked out g of 0, we're going to put that function, or that value, into g of x again, and we should have our final value for the composite function. So g of 0, so when x is less than or equal to 2, we must put it into this part of the function. So 0 minus 2, if we square that's going to give us 4, and then if we add 1, 4 plus 1 is 5. So g of 0 is 5, so what do we get when we put 5 into our function? So g of 5, so x is bigger than 2, because 5 is bigger than 2, so we have to put it into this part. So 4 times 5 is 20, 20 minus 7 gives us 13. So therefore, g of 0, that's a 0, believe it or not, is equal to 13. And there we have it, so that's the first 2 marks, nice and easy, hopefully. Part B gets a little bit trickier, so let's have a look at part B. So part B, we're asked to find all values of x for which g of x is bigger than 28. So don't forget we have 2 parts to g of x. We have when x is less than or equal to 2, so a restriction on the domain here. What we have is x minus 2 all squared plus 1. So we need to work out when that is bigger than 28, and we also need to work out when 4x minus 7 is bigger than 28. So the second bit here is a lot easier than the first one. So let's do the first one first, get that out of the way. So what we have is x minus 2 all squared plus 1 is bigger than 28. Bigger than 28. So what we can say is that x minus 2 all squared must be bigger than 27. So I'm taking that 1 across here. Oops. Must be bigger than 27. So now, let's have a go at solving this. So we're going to take the square root here, right? So if we take the square root, that's going to give me x minus 2. Square root of the left-hand side is going to be bigger than the square root of 27. So I'm going to split the square root of 27, so that's the square root of 9 times the square root of 3. So it's going to be plus or minus 3 root 3. So don't forget we can take the positive and negative square root. So we get plus or minus 3 root 3. In fact, actually, what I'm going to do is I'm going to get rid of that plus or minus just to illustrate another point. So the reason why is when we take the square root, we have a positive and a negative square root, right? But when I take the positive, the inequality stays this way. However, the negative square root will flip it. So what we get is x minus 2 would be less than minus 3 root 3. Which gives us 2 unique solutions. So therefore, x, or should I say a set of values, so x is going to be bigger than 2 plus 3 root 3, and x must be less than 2 minus 3 root 3. So we've got them 2 values now. Let's have a look at the next part. So when 4x minus 7 is bigger than 28, so this is hopefully a little bit nicer. 4x minus 27 7. 4x minus 7 is bigger than 28. So when is 4x minus 7 bigger than 28? So we're going to add the 7 across. So 4x is bigger than 35. So therefore, x must be bigger than 35 divided by 4. 35 divided by 4. But we have to consider now where these 2 inequalities are going to overlap, because we have 2 greater than values. So what I'm going to do is I'm going to illustrate this on a number line. So if this is where we say 0 is, what I'm going to have is I'm going to have this value all the way down here, so that's 2 minus 3 root 3. Okay, so that's my 2 minus 3 root 3. I've got 0. I also have 2 plus 3 root 3. and I also have 35 over 4. And each of these values is strict inequality, right? So this has to be less than, so we want everything to the left of it. That would be a value that's smaller. And we want these two to be greater than. So that's going to be down there like that. And then this one again will be everything to the right again. Now we need to consider where these inequalities are going to lie. So what we know is that, therefore, x must be less than these values down here. Because we want everything lower than it. X must be less than 2 minus 3 root 3. But be very careful for the greater than values. So don't forget, we can't say x must be bigger than 2 plus 3 root 3. We have to start from here. Because notice these inequalities are overlapping, but we have to start with the bigger one. So x must be bigger than 35 over 4. So hopefully that's okay. So that's part A and part B done. So part B has quite a bit of work to it. So let me just rub this out. So make sure you pause this if you need to take any of this down, guys. But I'm going to quickly rub it out now. So that's part A and part B done. So let's have a look at what part C has to hold for us. So part C is just a one marker. And all it's saying is we have to explain why H has an inverse, but G does not. So for a question like this, you need to understand why a function might not have an inverse. So a function might not have an inverse for a very important reason. And that reason is when a function is many to one. So remember, we have one-to-one functions and a many-to-one function. So G is a many-to-one. So is many-to-one. Many-to-one. So what that means is that the inverse does not exist. So G inverse. So I'm just going to write this shorthand, but this just means does not exist. Okay, so G inverse does not exist. But H is a one-to-one function. So for H to have an inverse, it must be a one-to-one. So H is one-to-one. H is one-to-one. So H inverse does exist. Like so. So that's all you need to put for part C. So if a function does have an inverse, then it must be a many-to-one function, where if it does have an inverse, it's a one-to-one function. And then finally for part D, we have to solve the equation H inverse of x is equal to minus a half. And this is the last 3 marks. So how do we do something like this? Well, what we need to consider for a question like this is taking the inverse. So h of x is this here. So h of x is x minus 2 all squared plus 1. So what I'm going to do is I'm going to work out the inverse of this first. So remember, what we do is we say h of x is going to be equal to y. So what we have is y equals, x minus 2 all squared, x minus 2 all squared, and plus 1 at the end. So what I'm going to do now to rearrange this is what we're going to do is we're going to rearrange for x. We need to get this in terms of x, and then we're going to flip at the end. So what I can do is I can take this plus 1 across, that's y minus 1 is equal to x minus 2 all squared. X minus 2 all squared. So what I can do here is take the square root. So therefore, well, I'm going to change it just the way I've written it, sorry. So x minus 2 is equal, so don't forget we have a plus or minus square root, so that's y minus 1. And then what we're going to do is we're going to add 2 to it. So therefore x is equal to 2 plus or minus square root of y minus 1. Now we have a plus or minus here. So we either know that x is going to be equal to 2 plus the square root of y minus 1, or x is going to be equal to 2 minus the square root of y minus 1. And we have to decide which way we pick this. And the way to pick this is you have to consider the graphs. So this is why I say a graphical calculator is really, really invaluable. Because what you're going to do now is put y equals x in. So we're saying x can be equal to this. So y is equal to x. So you're going to plot one graph of y equals x. And then you're also going to plot the other graph. So you're going to put 2 plus the square root of y minus 1. And you're also going to put y is equal to 2 minus the square root of y minus 1. Although you would change them to x, obviously. So you change that to x minus 1 and x minus 1 again. And then when you plot them on your calculator, you look for the intersection. So on the Casio graphical calculators, the intersection function tells you where the two graphs intersect. But for one of these, you'll get an error that there is no intersection. So what you obtain is that we need the minus. So what we're going to say is that 2 minus is the one we need. So 2 minus square root of x minus 1. Okay, so this is my inverse now. So therefore, h inverse of x is equal to 2 minus square root of x minus 1. So we've got our inverse. Now we just need to set it to equal minus a half. So if we set this equal to minus a half, 2 minus square root of x minus 1 is equal to minus a half minus a half. What we can do here is take this square root of x minus 1 across and take this half across if we want, or we can just take the negative across like this. So if I take the negative across, I'll take this 2 across, that'll become negative. So I'm going to get minus square root of x minus 1. So that's going to be equal to minus 5 over 2. That's minus 5 over 2. So minus a half minus 2 minus 5 over 2. And then if I square this, what I'm going to obtain is that x minus 1 is equal to a positive value. Obviously, if you square a negative here, this will become positive as well. So I'm going to do it over here. So therefore, x minus 1 is equal to 25. So 5 squared is 25. 2 squared is 4. So if we add 1 to this, so that's 4 over 4 to 25 over 4, x is equal to 29 over 4. And there we have it. We've solved the equation and obtained our x value. So it has a couple of tricky parts in it and a few little tricks you've got to be careful for, but overall, hopefully, not too bad of a question.